All right, we're ready to go. We're going to talk about the unit circle. Okay. That's okay. You can hear me. I don't see you. Try again. Okay, so as Brittany gets in, Jordan, are you getting in? Okay, so we're going to talk about a unit circle. Are you in? It doesn't, I don't see you. Try again. Yeah. That's weird. Okay. So unit circle typically has these three features. A coordinate plane. What's a coordinate plane?
I don't know.
What's a coordinate plane? Come on, guys. Coordinate plane.
This is week 8.
This is week 8 of the third quarter. Coordinate planes you learned about in quarter 1 of core 1. What's a coordinate plane?
I don't remember. That was a long time ago.
What's a coordinate plane? Come on, anybody? Yes, it's a graph. It is a graph. It's the XY coordinates. A circle with the center at the origin, and it has a radius of 1 unit. All right? Hence, unit circle. And the last thing, an angle at standard position that intersects the circle. All right? So, this is standard position. My x coordinate should be up because it's really like 90 degrees, right? That's just sad. Okay. Standard position of an angle when its vertex is at the origin. So here's the origin of that coordinate plane, right? And that would be the center of the circle. And that's where you measure your angle. Goes this way, right? Always goes to the left. You start at the x coordinate or x-axis and you go to the left to measure your angles. All right, that would be the initial side. And that's when the ray is on the x-axis. The other ray is the terminal side. Okay, now the example. This ray right here would be our what? What ray? What's this called? Actually, if we were talking about opposites and adjacents, it would be the adjacent side. But this, what we were just talking about, this is our initial side. All right? And if I go up this way, what's this one called? What's this side called? Come on, guys. Terminal side. All right. So what is this little symbol? Anybody know what this symbol is?
Cosine.
Nope.
Tangent.
Nope.
Zero with a line in it.
Zero with a line in it? It's called theta. It's a Greek letter. Okay. And it's the symbol that we use for the angle in a standard position. Okay? Theta. All right. So, measuring angles in standard position. The measure is positive when you rotate from the initial side to the terminal side in a counterclockwise direction. So you guys have to know which way a clock goes, right? Okay, so this is counterclockwise, right? But so many people do not have clocks, watches, that they're all digital now, you know. Okay, anyway, so we're going to measure in a counterclockwise position. And this side right here, let's do this again. What side would this be?
Your terminal.
What side would this be? Come on, guys.
Right side.
Starts with an I. Initial. Oh, God. All right. So what is this side then?
Your tan. No, your terminal.
Terminal. Yes. Whew. Okay. I'm about done for today. That took a lot out of me. All right. So that's how we measure a positive angle. If we want to measure a negative angle, we go from the initial side to the terminal side in a clockwise direction. So what side is this? Initial. What side is this?
Terminal.
Yes, terminal side. And this would be a negative angle because we're starting at the initial, going to the terminal in which direction?
Clockwise.
Clockwise. All right. Coterminal angles. These are two angles in a standard position, and they have the same terminal side. So coterminal, if I went this way, counterclockwise, I have an angle of 330 degrees, and if I go this way, I have negative 30. These two angles are coterminal because they have the same terminal side. Yes. All right, things to know about the unit circle. Absolute values of the x and y coordinates of the points are in where the inscribed angle intersects the circle are the lengths of the side of the inscribed right triangle. A lot of words. What does it mean? I'll show you. The y coordinate is always the sine. The x coordinate is always equal to the cosine. And the slope is the tangent. Okay? So, sine is opposite over hypotenuse, or the y over 1. Why is it 1? Why is it 1? What are we talking about? What kind of circle? What kind of circle is this? Say again? Unit circle! And that's why it's 1, because it's 1 unit. Okay, so the hypotenuse, thank you, is the radius, and the radius of this circle is 1. All right, so opposite, adjacent, tangent is y over x, or opposite over adjacent. I don't think that we go into cosecant, secant, and cotangent, but it's hard to not talk about these because they are just inverses of the others. Okay? Make sense? These over here are ones you need to know. All right. Pythagorean theorem. A squared plus b squared is equal to c squared. If, okay, you're thinking about this circle. All right, we're thinking about this lovely circle. And so tell me, what is this that I just drew? Could be the terminal side, but it's also not the initial, you said terminal. It's also the hypotenuse, right? So if we were looking, all right, so I'm not going to worry about this problem up here right now. We're going to just talk about this, and we're going to say that this angle is, let's make it something, 30 degrees. All right? So our hypotenuse is 1, right? Our x value, cosine, remember, is x over 1. Sine is, what is sine?
Y over 1.
Y over 1. So let's do this one too. Tangent. Say again. X over y, so close. It's y over x. But you were right. It is a combination, okay? Oh my gosh, snowing. All right. So we're talking cosine of 30 degrees. We're going to put in our 30 here. Now, there's something that I just learned this year because this unit circle used to bug me because I couldn't remember these numbers. But this number down here is 1, 0, right? On this circle, on this part right here, this is square root of 3 over 2 and 1/2. If I were to draw this, this is 45. This is 1/2, 1/2. This point up here is going to be 1/2 square root of 3 over 2. This point up here is what? What is my x coordinate right here? 0, 1. My x coordinate is 0, my y coordinate is 1, right? Now, the important thing about the unit circle is these standard angles, 30, 45, 60. These are the standard angles, and these numbers over here are going to be the same as the ones over here, as the ones over here, as the ones over here, but different signs, right? Make sense? What are the signs for x and y in the second quadrant? Negative, positive. The signs. All the x values are negative in the second quadrant. All the y values are positive, right? What about in the third quadrant? Say again. Negative, negative. They're both negative in the third quadrant. What about in the fourth quadrant? Positive, negative. All right, so if you remember, yeah, exactly. If you remember the signs and you only have to remember these numbers, you can find the angle measurements or the sine, the cosine, the tangent for all the ones in the other quadrants. Does that make sense? Okay, so let's go. Okay, we're not going to worry about this one because I drew all over it. All right, so when the unit circle is dilated, that means either it's made bigger or smaller so that its radius is not equal to 1. It's not a unit circle anymore, right? So that just means that the sine, the cosine, and the tangent, and the cosecant, and the secant, and the cotangent are a little bit different. Oops, sorry. And they're different like this. Does that make sense to anybody? So the sine now is still opposite over hypotenuse, which is y, but the hypotenuse is no longer 1. The hypotenuse now is just the radius of the circle. All right, the hypotenuse, remember, if we talked about the x squared plus y squared is equal to r squared, and that's our radius. Okay, so the cosine is always adjacent over the hypotenuse, so that's x over r. Tangent is opposite over adjacent. And again, these over here, I can't remember, but I don't think we talk about them. Okay? So these are the ones you have to remember. And it's kind of important. All right. So if you know any point through which the angle passes, you can find the radius of the circle with the center at the origin and passing through the given point by the equation, this lovely Pythagorean theorem. And what we have is x squared. Can you guys see that? Y squared is equal to r squared, because here's our circle. And there's our triangle, our right triangle. This is our x, this is our y, this is our r. And that's if our unit, it's not a unit circle. That's if the radius is something other than 1. Okay? All right. So, build a grid using the knowledge of the quadrants, right? And that would mean in the first quadrant, what are our x and y values?
1, 0.
What are our x and y values in our first quadrant? I can hear your music.
1, 0.
What are the 1, 0? No, what I mean is in the first quadrant, what are our signs of our x and y values? That's what I meant. First quadrant. Let's draw this up here. First quadrant. What's the x values and the y values? What are the signs of all the x values? Positive, positive. Okay. SOHCAHTOA, what does that stand for? Sounds like an Indian name, right?
Yeah.
What this stands for is sine, the S stands for sine, is equal to the opposite over the hypotenuse. What's the C stand for? Cosine, and that's equal to adjacent over hypotenuse.
T is your
T is your
tangent.
tangent, and that's opposite over adjacent. Okay, so this is just a little, what are those called? I don't even know, to help you remember. Okay, so quadrant 1, 2, 3, and 4. Okay, we're going to add to the grid the signs of the x and y values. All right?
Yeah.
You guys told me that. Ryan told me that. John told me that. All right. So we want to determine the trig functions that will have positive values in each coordinate, in each quadrant. So all of them, sine, cosine, and tangent, all have positive values, right?
Sure.
In the second quadrant, the sine and the cosecant, we're not so worried about the cosecant. The sine has positive value. Cosine is negative. Tangent is negative. Third quadrant, tangent is positive. What's negative? Cosine and sine. What about in the fourth quadrant? What things are positive in the fourth quadrant? Cosine. The x values are positive, so cosine is positive. Tangent is negative, sine is negative. Yes, it does. Yes, it does. Okay, once you think about it, that's it. Say that word.
What?
Mnemonic. Okay, that's a mnemonic. All students take calculus, right?
ASTC.
ASTC means all of them. The A stands for all. The S stands for sine. The T stands for tangent. And the C stands for cosine. Those are what's positive. And you just need to think about that. A, S, T, C.
This is calculus.
This is no calculus. Okay. Make sure you go in and write it down.
What is this? Trigonometry?
Okay. This is trig, yeah. Okay, so what happens to, you can't see this, the sign for 0? 90, 180, 270, 360.
How do we know what 0 is?
Oh, sorry. Okay, so when you think about it, let's look at our, I'm going to leave this white. Does this make sense still? This is 0 here. This is 90 here. This is 180. These are the degree measures. This is 270, and this one over here is also 360. So, what happens to the sine for 90 or for 0, 90, 180? So the sine here is what? Cosine is positive. What's sine? Is sine positive there? Okay, what about up here? Cosine is 0. X values are 0, right? Right up here. What about here? Y values are 0. What about down here at 270?
0.
What's 0? Yes, but what?
Y.
X. And over here at 360,
Your Y values.
Y values are 0. So, what does that tell us? If sine is y over r, right? Then that means that here and here, what's my sine? 0 and 180. What's the sine?
What?
Focus, Jordan. Look, right here. What's your y value when your angle is 0 or 360? Right here. Right here. Come on, guys.
0.
0. If your y value is 0, 0 over any number is
0.
0. So your sine is 0. Okay, what about 180?
0.
0. What about 90?
90. 0.
Sine is y over radius, so it's whatever your y value is, right? Does that make
So it should
sense?
be 90.
It's 90 degrees. Here we go. We're going to find the measure of the angle between 0 and 360, and it has a coterminal angle with 600. All right? So what we do here, and this is, I looked to make sure that this was part of the problem, and this is part of one of your problems that you're going to be doing. You start with your 600, right? Subtract 360, 240. Okay, what about 180 degrees? We want to find the measure of an angle between 0 and 360 that has a coterminal angle with 180 degrees. Okay, so
440.
let's see, 360 and 180, 440. It's got to go the other way.
540.
Or it's got to
360 and 180 is 80 degrees.
360 plus 180 is 80. Is that
But
what
you
you
said minus.
Oh, minus. No. Okay, we're going to start out with 180 degrees. We're going to subtract 360. What do we get? Negative 180. So if we're going this way for our positive, this way is for our negative. Make sense?
Sure.
Yes? Good.
This is so
It is a little bit complicated. But that's why you're in Core 3, because you've passed the easy stuff and it's time for a little bit more complication.
Why is this necessary?
Make us cry. Nurse it.
This is necessary. Why is this necessary? Anybody? Anybody?
No, you're the teacher.
Why do you think it's necessary?
I don't. To be honest.
You don't? What are you going to be when you grow up?
Not doing this.
What are you going to be? What do you want to do?
Mm-mm.
Don't know? Okay, so I'm going to make you guys write a paper.
Never mind.
Yeah, it's exactly necessary for architecture. That's the big thing. But what else? Space travel. They have to think about angles, how they're going to get to the moon, what the angle of trajectory. Yeah.
How many people here are going to go to space? Not me.
Okay, Jordan. Engineering, yes, I can vouch for that. You're going to take much more than trig to be an engineer.
That's really
I don't know, John. What is your career? Or what do you want to do? Right now your career is a student. You want to be a chef.
Same.
Okay.
McDonald's.
Well, I don't know that trigonometry is so much necessary. However, math is necessary because you need, and you know what? It is necessary because trig is all about ratios. Whoa, whoa, let's think about this. It's about ratios. What do you have to do when you cook? You have to think about, okay,
I don't know.
ratios. You have to think about ratios. And the reason that you have to think about ratios, proportions. That's the same thing. If you're going to cook for just you and someone else, that's pretty easy. But if you have to cook for a whole big crowd of people, you got to think, this is what I started with. Now I've got to make the ratio so that it works for 50 people, right?
Somebody's calling you.
Oh, yeah, measuring. All right, guys. My phone is buzzing. So, any questions? If you have no questions, keep going. John, you are almost done.
John is there.
Anybody else?
I have a question.
Oh my gosh, you're already done with this week, so you are done.
We don't have a final.
Nice. If I make one. Do you want a final?
No.
Okay, all you guys are getting them. All right, guys. That is it for me.
I'm not coming to school.
So, no questions. You guys are good to go, and thank you so much. Remember, attended
You're very
in the
welcome.
webinar, and you have 4 points. Excellent. All right. Later.